So we have to make some one assumption, that is, it is found that rotor MMF is approximately 85% of stator MMF. So if your stator MMF is 100%, then your rotor MMF is found that it is 85% of stator MMF. So using above relation, you can calculate IB, that is rotor bar current. IB is equal to 0.85, that is 85% of stator MMF. Stator MMF is nothing but your stator MMF per slot. It is nothing but your 6 times ISTS, that is ampere turns of stator, divided by number of rotor slot, SR. SR stands for your number of rotor slot. IS is your stator current. TS is your number of stator turns per phase. After that, SR, number of rotor slots. And you know why this 6 is multiplying here, because 6 is nothing but number of phase 3 into 2, which is 2 coil sets. So 3 into 2 equal to 6. So here we have calculated IB, which is rotor bar current. Now if you know the value of rotor bar current, then you have to select some current density for rotor bar, that is delta B. And remember, it could be selected between 4 to 7 ampere per mm square. So if you know the delta B, that is current density in rotor bar, then it is very easy to calculate area of each bar. So IB upon delta B, which will give you the area of bar in mm square, because your IB it is in ampere and delta B it is in ampere per mm square. So area you will get it in mm square. Now once you know the value of area of rotor bar, you must select shape of the rotor slot. There are two types, or there are two shapes of the rotor slots. One is closed slots, second one is semi-enclosed slots. Now remember, in case of stator we are having two type of slots, that is open slots and semi-enclosed slots. But in case of rotor we are having closed slots and semi-enclosed slots. So semi-enclosed slots, they are common in between stator and rotor, but here closed slots are only for rotor. Now consider closed slots. So this is the diagram for closed slots. Now why we are preferring closed slots? Generally closed slots are preferred for small machines. Now what is the advantage of using closed slots? That the magnetizing current is less. If you are using closed slots in your motor, then the magnetizing current is less, and if your magnetizing current is less, automatically your power factor will improve. So if you want better power factor, you must prefer closed slots. But remember, we are using the closed slots for small machines, that is for small motors. So under closed slots, the leakage reactance is large, limiting the starting current but reduced overload capacity. So though it will limit your starting current, that is magnetizing current, but it will reduce your overload capacity. That's why we are preferring these type of slots for small machines. Now second one, what is the advantage of using semi-enclosed slots and disadvantage of using semi-enclosed slots? So these type of slots will give you better overload capacity. Okay, sometimes rectangular slots are preferred. This is your rectangular slot as it becomes deeper as compared to round slot. This is round slot. So this is a rectangular slot and this one is round slot, that is circular one, which will give you the more leakage reactance. But here one drawback is there in case of semi-enclosed slot, which is it will give you large starting current. This will decrease your power factor, or this may lead to your poor power factor. So this closed slot will give you better power factor. Here semi-enclosed slots will give you poor power factor, but it gives increased leakage reactance and high flux density at the root of your teeth. So this is the some advantages as well as drawbacks of closed slots as well as semi-enclosed slots. But the most important difference you must remember is closed slots are preferred for small machines and semi-enclosed slots are preferred for medium as well as large machines. Design of end rings. Now, as you know, the structure of rotor. The squirrel cage